standard deviation. So we have 3 steps to finding the sample standard deviation. Starting with step 1, you calculate the sample mean, which for team 2 on the front we already did. For team 2 on the front, X bar was 75 inches, just like it was for team 1. Step 2 then is to construct a table to obtain the sum of the square deviations. So I'm going to make my table over here. I've got 5 different players, so I'm going to make sure I have 5 spots. And then I'm going to fill in my X values. And then we're going to do find our differences, right? X minus X bar. And then we're going to square the differences. So we just need to write in our heights. Man, you're fast. 67, 72. Good. 84. And then we subtract the mean from each of our X values. 67 minus 75. What is it? -8. All right, and then keep going down the line. -3, good. 119. Then we square each one. So -8 squared is 64. It should always be a positive number. When you're entering it in your calculator, you need to put it in parentheses before you square it to make sure that you get the accurate answer when there's a negative value. So 911 and 81. Table done. Step 2, check. Step 3 is apply the definition in this box up here to determine the sample standard deviation. So I'm going to find my sample standard deviation by adding these all together, dividing by n minus 1, that's the variance, and then square rooting it to get the standard deviation. So I'm going to do 64. I'm going to put the total down here. Save ourselves a little bit of work underneath this radical. What do I get when I add all these together? So my total of my differences squared is 156. So I'm going to take that 156, divide by n minus 1, which again is 4. N is the number of data points. So that's something that we learned when we practiced from section 3.1. When you practice the mean using our new notation, N is the number of data points. So then we're going to take the square root of 156 divided by 4, which I highly recommend that you do all in one step to get your most accurate answer. In order to do that in one step, though, you would have to put the 156 divided by 4 in parentheses. So you can type into your calculator second button, square root, parentheses open up automatically. 156 divided by 4, close parentheses, and we get 6.24499. So let's go with 6.24. Approximately 6.24 is the standard deviation for heights of our Team 1 basketball players. Oh, that was team 2. My bad. For our team 2 basketball players. So in comparison, who has the larger standard deviation? Team 1 or team 2? Team 2 has a larger standard deviation, also variance. Not surprising, right? We had a 5-footer and a 7-footer on team 2 and all 6-footers on team 1. But so these are a lot better descriptors and a lot more accurate even than the range. They give us a lot more information. Below, you can see a little bit of a sneak preview into what we'll be doing tomorrow. You see a dot plot where in this example, our data set has an average of 50. You see on the dot plot how they put 50 right in the middle? When we're talking about standard deviation, again, the definition of standard deviation is going to be comparing our data points to the mean. So the mean goes in the middle of that dot plot. And you can see here's our standard deviation of 7.4. So to find out these two lines here, which are marked, we would add the 7.4 to the mean and subtract a 7.4 from the mean, giving us one standard deviation from the mean. Then we go up by 2. You can see that that work is shown right here. Going up by 2 would just be to do 50 plus 2 times 7.4, giving us 64.8. So that's where that number came from. And subtracting 2 standard deviations, that's where this number comes from. And then 3. It only goes out to 3. Not because we ran out of space, but because there's kind of a known observation. It's a rule. We call it a rule. It's called the 3 standard deviations rule. Read that for us, please, Eliana. The 3 standard deviations rule at the very bottom.
Almost all of the observations of the data set lie within 3 standard deviations intersect.
So there you go. That's why there's only 3. Notice on this second figure, it's spread out a lot more. So you can imagine the standard deviation is larger. The standard deviation for this second set, and you can see it right here, is 14.2 compared to 7.4. So it's spread out. And you see all of the data points. There's one little guy in here outside of the second, but before the third standard deviation, same thing here. But all of the data points in these 2 sets of data are contained within 3 standard deviations of the mean. And there's more that comes with that, and we'll talk more about that on Wednesday.